are going to be looking at using the properties of addition in order to add fractions or add fractions. So make sure you have your book and you are taking notes. Remember, I am checking. We are on lesson 6.11. Let's go ahead and begin. So here we are. We are on lesson, like I said, 6.11. If you scroll down, we are on page 295. Again, page 295. And we're going to start by writing our objective. When we write our objective is so that you can understand or see what is it that you should expect to learn today. Okay, so the objective is, let's write it in blue. Objective. And today we will, you know what, I think I'm writing with, no wonder, I'm writing with the math tool. Okay, so the objective, we will add fractions and mixed numbers with unlike denominators using the properties. So here we're going to be using the properties. Now this is something that you will continue to see in 6th grade and 7th grade. So, and you have been seeing this since probably 3rd grade, right? And so we want to review this because this will be very, very important. So, we will be adding fractions and mixed numbers with unlike denominators using the property. So we're going to review commutative property, and the associative property. And so here's where we're going to make a connection. You can use properties of addition to help you add fractions with unlike denominators. So this is going to be very similar when we were using whole numbers, but now we are also including fractions. And so the commutative property, if you remember, commutative property says that you can change the order of your addends. Remember, when I say addends, it's the numbers you're adding to find the sum or addition. So commutative property says that you can change the order. So the key word here is change the order. Repeat it after me. Change the order. And then we have the associative property, which is our second example. And our associative property says that we can change the grouping and it'll be the same. You will have the same value, the same answer. So if you have a group of numbers that you're adding, you can change the grouping. And when we're saying that we're changing the grouping, we are talking about parentheses. So I can group different addends and I will still have this, it will be equal to the same. So keyword, commutative property, change the order. Associative property, change the grouping. And that is mainly the gist of it. So one thing that you have to remember, don't forget that when we do parentheses first. And that's the reason why this is important, because the parentheses tell us what operation to do first. In this case, here in this example, 2/9 plus 1/8 will be added first. Okay, so let's look at the example. And remember, unlock the problem. Every time you see the little world icon that says real world, that means it's a word problem with that connects to the real world. And we are applying our steps, which are read. Remember, we went over these in class. Read, highlight. Well, I should write it out. Highlight. And let's move it a little bit this way. Jot, note, answer, and check. Okay, so remember, highlight. Why do I keep writing it like that? So these are our steps. Remember, we have a word problem. So we're going to read it at least 2 times. Here we go. Jane and her family are driving to Big Lagoon State Park. Wow, how did I read that? On the first day, they travel 1/3 of the total distance. On the second day, they travel 1/3 of the total distance in the morning and then 1/6 of the total distance in the afternoon. How much of the total distance has Jane's family driven by the end of the second day? Okay, I know we're talking about traveling, right? And distance. I need to read it again to get a better understanding what the question or what is the problem telling us. So now I'm going to get my highlighter to underline the important or to highlight the important information. All right, so we start. Jane and her family are driving to Big Lagoon State Park. Okay, it's a park. They're driving to this location. It says on the first day, they travel 1/3 of the total distance. So I'm going to actually underline this is on the first day. So this is day one. They traveled 1/3 of the total distance. Let's see, do it more. Okay. On the second day, they travel 1/3 of the total distance in the morning and then 1/6 of the total distance in the afternoon. So we have, and sometimes the circling is easier, right? We have 1/3 here, second day 1/3 in the morning, and then 1/6 in the afternoon. Now, what is the question ask? What is the problem asking? How much of the total distance has Jane's family driven by the end of the second day? So if we want to know how much they traveled by the second day, that means that we're adding day one, morning of day two, and afternoon of day three. So that means we're adding, right? So we are adding day one and day two. So initially we can start off with 1/3 plus parentheses to represent day two, 1/3 plus 1/6. Now, because we have grouping here, because we have parentheses, we will apply the associative property. We are in order to easily or more easily add these fractions. I want to group the fractions different. I want to change the grouping. So initially, I have 1/3 plus 1/6, and remember that when we're doing order of operations, we do parentheses first. So we would have, if we follow the way that it's here, we would add 1/3 plus 1/6 first. But why would I not want to add that first? Think about it. Why would I want to add 1/3 plus 1/3 first instead? Well, I will tell you. The reason why I would want to add 1/3 plus 1/3 first is because it'll be easier because they have the same denominator. So I'm going to apply the associated property to change the grouping. I want to put my grouping with 1/3 plus 1/3 first. So I'm going to rewrite it here. I'm going to use my math tool, and I'm going to do 1/3 plus 1/3. Oops. Okay, and then I will add 1/6. Okay, so here, because I have now changed the grouping to add 1/3 plus 1/3 first, I don't have to find the equivalent fraction of this number twice because they have the same denominator. So 1/3 plus 1/3, remember, when I'm adding fractions, I add the numerator first. And the denominator stays the same. We do not add them, the denominator, only the numerator. So then now, I can now add 1/3 plus 1/3 is 1 plus 1 is 2, and the denominator is 3. And then I'm adding 2, 1/6. Okay. So here it said use mental math to add fractions with like denominators. That's exactly what we did. Now we need to write the equivalent fractions because now we just need to add 2/3 plus 1/6. But our denominators are different. Now I already know that 6 is a multiple of 3. So that means that I can use 6 as a common denominator. So we're going to find the equivalent fraction of 2/3 that has a denominator of 6. And so I think 3 times what number equals 6? Remember, when you're finding the equivalent fraction, you are multiplying the denominator. You need to find what you multiply the denominator in order to get 6, because that's a denominator that we want to use. So 3 times 2 equals 6. So I'm going to multiply the denominator by 2 to get 6. And if I multiply the denominator by 2, I need to multiply the numerator by 2. So that 2 times 2 equals 4. So my fraction here is going to be 4/6. And I'm adding 1/6. I'm just bringing it down from here. So now I have 4/6 plus 1/6. Remember, we're adding only the numerator, which is the top number. 4 plus 1 is 5. And then the denominator is 6. Okay. And so the answer is, so Jane's family has driven 5/6 of the total distance by the end of the second day. Ooh, that means they're pretty close, right? Because they're very close to reaching 6/6. So grouping it differently makes it easier, right? Because if not, I would have to find the equivalent fraction of each, which in this case wouldn't affect as much because it's the same fraction. But let's say that this was a different fraction with the same denominator, then it would help that. So let's go ahead and try one more example, okay? Now here we're going to be using two properties, and you will see how. Here the question is saying, add 2 5/8 plus 1 2/3. And then we close parentheses plus 1 1/8. So we're going to be using commutative property and associative property. Now, what is a commutative property? Remember, commutative property changes the order of the fractions. Now, here we want to switch the order of the 2 5/8 and 1 2/3 because remember that associative property only changes the grouping. If I'm switching numbers, I'm changing the order. I cannot include in my parentheses 2 5/8 and 1 1/8 because they're not next to each other. I'm going to repeat that because, you know, it might be, it take a little bit to follow along. So let me repeat this. Remember, commutative property changes the order of your addends. Associative property changes the grouping. I want to use the commutative property because I need to change the order of these numbers. I need to switch them. Why do I need to switch them? Because I need the fractions with the same denominator to be next to each other so that I can change the grouping, so that I can group 2 5/8 with the 1 1/8. Right now, I can only switch it to change it like this, and it doesn't help because 3 and 8 are different denominators. So what I need to do is change the grouping. So I'm gonna swap. I'm gonna switch 2 5/8 and 1 2/3 so that 1 2/3 is first. So here I'm gonna write 1 and I have to do 2/3 first. 1 2/3 first. Let's move it a little bit higher. And now, so I'm swapping, and so now my 2 5/8 will be the second addend. So 5/8, add the 2 in the front. Okay, so I swap these, and then of course we have here the 1 1/8. So now that I have swapped or changed the order, because that's what the commutative property is, now I will apply the associative property. Use the associative property to group fractions with like denominators together. So what I'm now going to do is, okay, here they change the grouping. I'm sorry. So here, what I'm going to do now is instead of grouping 1 2/3 plus 2 5/8, I'm going to group the fractions that have the same denominator. So here I will bring down 2/3 and with the whole mixed number. And here we have, so I'm just bringing my numbers down, but we're changing the grouping so that the fractions with the same denominator are together. All right. So now it should be easier for me to add these two because I can do it mentally since I'm adding and they have the same denominator. So I will add the numerator. 5 and 1 is 6. And we keep the same denominator, which is 8. And now I just add the number, the whole number. 2 plus 1 equals 3. Okay, let's go ahead and move this over here. And then we just bring down the 1 and 2/3. Our next step is now to add 1 and 2/3 plus 3 and 6/8. But now we need to find the equivalent fractions because we need to change them so that they have the same denominators. So we're going to write equivalent fractions with like denominators before we can add. So I'm going to list here my multiples of 3 and 8 so that I can figure out what what denominator I will be using. I'm going to list my first 5. 3, 6, 9, 12, and 15. And then for 8s, I have 8, 16, and it looks like I'm going to have to keep going with the 3, and I can still go back and do that. 24. And I'm going to stop there, and I'm going to keep going with the 3, 15, 18. So I'm adding 3 each time. You know how to do this. 21 and 24. So it looks like I'm going to be using 24 because that's the least common denominator. Okay, so we decided to use 24. So now I need to find the equivalent fraction. Let's start off. I'm going to do it here to the left. Let's start with 1 and 2/3. I'm going to find the equivalent fraction of 1 and 2/3. So I know that my whole number is going to stay the same. And the chosen denominator is 24 because that's the one that is I can use with both. So now I think, remember, your denominator that you pick should be a multiple of 3. So all you need to find is what number multiplies with 3 to get 24. You can always go back to your multiples that you wrote to figure that out. 1, 2, 3, 4, 5, 6, 7, 8. So if I multiply 3 times 8, I get 24. And now I'm going to multiply the numerator by that same number, 8. 2 times 8 is equal to 16. Okay. So that means that my equivalent fraction for 1 and 2/3 is 1 and 16/24. So that's what I'm going to write here. 16 over 24, and the whole number is 1. Now I'm going to find the equivalent fraction of 3 and 6/8. So I have 3 and 6/8. Oops, can't do that. 6/8. I have to write the fraction first and then the whole number. So I have 3 and 6/8. In whiteboard, you can write the um, you can write the whole number first, but not in Kami. Okay, so I have 3 and 6/8. I'm trying to find the equivalent fraction. My whole number stays the same, and the denominator that we're using is 24. So I will write 24 here because that's what we're using. And now I think 8 times what number equals 24? Of course, 24 is, we know it's a multiple of 8. So we think 8 times what number? Well, 1, 2, 3. 8 times 3 equals 24. So if I multiply the 8 by 3, I need to multiply the 6 by 3. 6 times 3 is equal to 18. Okay, so that equivalent fraction is 18 over 24 with the whole number of a 3. So now that we have the same denominator, we can add 16 plus 18. This is math that you can do in your head. because you know that 6 plus 8 is 14, and then you add the tens, 1, 2, 3, so that's 34. That's 34 over 24, and then we add our whole numbers. 3 plus 1 is 4. Now, do we stop here? This is where you need to check, okay? You cannot leave an answer with a fraction that is greater than 1. Why do I know that this fraction is greater than 1? Because my numerator is bigger than my denominator. Your numerator should be smaller than your denominator. If it's 1 or greater, you have to rename it so that you write it as a whole number. So here, the way I'm going to do this is I'm going to take out that whole number by subtracting 24 from the numerator and then adding it to the whole number. So 34 minus 24, because 24 over 24 is equal to 1. So 34 minus 24 is 10, right? And the denominator stays the same. And now I'm going to add that whole number to the 4. So that would become 5. Okay, again. Now, am I done? No, I am not done. I still have other steps. Let me see, I'm trying to move this. Okay. So again, remember, because this fraction is greater than 1, I needed to take that whole number or that 1 by subtracting 24 over 24 and then renaming it as a whole number. My next step now is to simplify. This is not in its simplest form. Okay, so right now we renamed, right? This is the renaming. Let me write it here, rename. And now I need to simplify. Simplify. So I'm going to simplify. And I know that I have to simplify because both of my fractions, the numerator and the denominator, are even numbers. So I know for sure that they are divisible by at least by 2. So if I divide 10 and 24 by 2, I get 5 twelfths. Okay, so I have 5. So 10 divided by 2 is 5. 24 divided by 2 is 12. I'm just cutting it in half, right? Both numerator and denominator. And the whole number stays the same. So 5 twelfths, is that my simplest form? Yes, because I cannot divide 12 by 5 or any other number. And both numerator and denominator, I cannot divide by the same number without getting a remainder. So my answer is 5 and 5 twelfths. And we will be practicing more simplifying. That is something that I want to dedicate a date for. But I wanted to finish this lesson first, and then we're going to go back and cover the adding and subtracting fractions with the fraction strips and simplifying and practicing finding equivalent fractions. Okay, this is the end of this lesson. We will practice more during class, and you will have a couple problems for you to try after this video. Thank you for being here. Thank you for getting to the end. I appreciate that you value the work in these videos. See you in class.